Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph this linear inequality. And to do that, there's a couple steps that I want to be able to follow. The first thing we want to do before we even get started graphing is identify, is our line going to be dashed or is it going to be solid? And since I have an inequality symbol that's going to be less than, I know it's going to be dashed. If it was less than or equal to, or greater than or equal to, it would be solid. But when it's just less than or greater than, it's always going to be dashed. So now I understand that my boundary line is going to be dashed. The next thing I want to do is I want to be able to graph this. And the easiest way that I prefer to graph is when it's in slope-intercept form. Well, this equation is not in slope-intercept form as it is right now, so I need to rewrite it in slope-intercept form. So to go ahead and rewrite it into slope-intercept form, what I'm simply going to do is isolate my y. So to do that, I need to add 2 on both sides. And I have negative y is less than 2x plus 2. Now, to undo the negative 1, undo multiply by negative 1, I'm going to divide by negative 1. But remember, just like when we're solving one variable inequalities, whenever you multiply or divide by negative 1, you need to flip the sign. So now I have y is greater than a negative 2x minus 2. Now that I have this in slope-intercept form, it doesn't matter if it's an inequality or equation, the slope and the y-intercept are going to be the same, so we're going to want to identify them. So our slope is equal to a negative 2, and our y-intercept is equal to negative 2 as well. So they're exactly the same. But how do they differ? Well, remember the y-intercept is a coordinate point. It's where the graph crosses our y-axis, as that's your x-axis. So I go down negative 2 from our origin 0, which is like our start. So I'm going to go down 2 units and then plot the y-intercept, which is the coordinate point, 0, negative 2, whereas just the equation, it's just represented as the y value. Now I need to identify what the, I need to identify another point on this line by using the slope. So to do that, we need to remember that slope is a ratio. It's the change in the value of my y-coordinates over the change in the value of my x-coordinates.
Mr. Crawford, please buzz the main office. Mr. Crawford, please buzz the main office.
So to do that, it doesn't matter if it's negative 2 over 1 or 2 over negative 1, but let's just use negative 2 over 1. So if the change in my y-coordinates is negative 2, I'm going to go down 2 units. And if the change in my x-coordinate is positive, I'm going to go over 1 unit. And again, the reason why I say this is now all I need is 2 points to be able to graph my line. But let's say I wrote this as 2 over negative 1. That means the rise would be up to the left one, which is also on the point. And you can just keep on continuing your slope, but we only need to do 2 points. I forgot. Remember I said from the beginning this is dashed? The reason why, and I think I got carried away talking, is when we're drawing our line between our values, we got to make it sure it's dashed because any point that's on the line is not going to make your inequality true. It's not a part of the solution. But we need to test where are we going to shade. So to do that, we always like to test the origin, which is at the coordinate point 0, 0, unless your line goes through the origin. Then you have to pick a point that's not on the line and not on the origin. But since this doesn't go through origin, I'm going to test it. So all I'm simply going to do is you can plug it into this equation, or you can plug it back into the original equation. So I have negative 2 minus 0 less than 2 times 0. Well, negative 2 minus 0 is just negative 2. 2 times 0 is 0. So that is true. Since that is true, we're going to shade towards our coordinate point. So there you go, ladies and gentlemen. That is how you graph a linear inequality. Thanks.